In the last video, we ended up with a discussion on a common difference. And if we do find a common difference, we know that we're dealing with a linear sequence. If we don't have a common difference, then our sequence is non-linear. In this video, we're going to go over a few examples to better your understanding of sequences. Let's say you were given the following sequence: -8, -3, and 2. And you had a question that asked you to list the next 4 terms in this sequence. How would you go about doing that? Well, the first thing that we can do when we're looking at a sequence like this is let's try to find a common difference and see if one exists. Let's see if this is a linear or non-linear sequence. So we know that the way we're going to find our common difference is by using this formula: Tn minus Tn minus 1 is equal to d, and d is how we denote our common difference. So let's do T2 minus T1. T2 minus T1 is going to be equal to -3 minus -8, and that is going to be equal to 5, because -3 plus 8 is equal to 5. Now let's do T3 minus T2. T3 minus T2 is equal to 2 minus -3, which is the same thing as 2 plus 3, which is equal to 5 again. So already, because we have the same number here, our d is the same in each of our terms, we do have a common difference and we have a linear sequence here. So we know that we are going to be adding 5 in each of these terms. And so we can pretty easily figure out our next 4 terms just by adding 5 to each of the terms that we get. So let's add 5 to 2. 2 plus 5 is going to be equal to 7. 7 plus 5 is going to be equal to 12. 12 plus 5 is equal to 17. And 17 plus 5 is equal to 22. And so just by finding our common difference, we can easily list the next few terms of the sequence here. Now let's look at another example. Let's say you were given the following sequence: 3, 8, 13, and 18. And let's say you were asked to determine the value of T6 and T7. So this question is asking you to determine what our 6th and 7th terms are going to be if we're given the following sequence. One thing that we can start off with is to first see if we can find a common difference. Let's start with T2 minus T1. 8 minus 3 is equal to 5. 13 minus 8, that's T3 minus T2. 13 minus 8 is also equal to 5. Let's do T4 minus T3. 18 minus 13 is also equal to 5. So we have a common difference. This is a linear sequence. And so we know to go from one term to another, we're going to be adding 5 each time. Now we could determine what our 6th and 7th term are just by adding 5 to each of these terms and going one by one until we get to T6 and T7. But another approach that we could try is to find our general formula for this sequence. And when we find our general formula, we can apply it to any term. Even if we were asked to find the 100th term of this sequence, we could easily apply that general formula and find those terms without having to write down each of our terms term by term. So let's actually look at the sequence a little bit closer and try to find a general formula. So I like to write down each of my terms like this. And when we have a common difference, it's kind of easy for us. So when we have something like this, we know that in our first term, this is T1, this is T2, this is T3, and this is T4. So in our first term, we're going to be starting off with 3. And right now we're starting off with 3. We're not actually adding any 5s yet. And you can look at that by just looking at our 3 here. We're at the 3. We haven't gone to 8 where we've added a 5 here. So we can write this down as 3 plus 0 times 5. Now if we look And let me just circle that so you know which term I'm talking about as I go on and on. So now let's look at our second term. If we're looking at our second term, and we need to find a general formula where we're starting from our first term. So we're starting from 3. And we need to be adding, here we can see that we've added 1, 5. So we can do 3 plus 1 times 5. And that's just the same thing as 3 plus 5. And 3 plus 5 is 8. And now let's do that with our third term here. If we're trying to find the same pattern for our third term, we're going to be starting with 3. And now we're adding 5 once and twice. We're adding 2 5s. So 3 plus 2 times 5. Now if we go to our fourth term, we can see that we're adding 5 once, twice, 3 times. So we're adding 3 5s. So starting from 3, we're going to be adding 3 5s. And we can confirm that this is correct. We know that we did this here. 3 plus 0 times 5 is just 0, so this is just 3. 3 plus 5 is 8. 3 plus 2 times 5. 2 times 5 is 10, plus 3 is 13. 3 times 5 is 15, plus 3 is 18. So this formula, we know that this does work for each of these terms. And another thing that we can notice is that in each case, this part of our equation and this part of our equation and this plus sign here is the same. This is always going to remain the same. And the only thing that we're actually changing is this number here. This number that I've circled in pink. This is the only thing that's actually changing. And now if we try to write that down in terms of n, I'm just going to write that down here on this side to make it easier. So let's write down the part of our formula that's not changing. 3 plus something times 5. And again, I've just written down the part of our formula that's staying constant. We're always doing 3 plus something that keeps changing times 5. And how can we write down that number that we are multiplying by 5 and adding 3 to in terms of n so that we can find a formula for Tn is equal to n? Well, over here we have T1, and when our n is equal to 1, we're multiplying by 0. Here we have T2. When our n is equal to 2, we're multiplying by 1. Here we have T3. When our n is equal to 3, we're multiplying by 2. And here we have T4. When our n is equal to 4, we're multiplying by 3. So each time we're going to be multiplying by n minus 1. And again, we can validate that this is correct because let's try it with each of our terms here. If we're looking for our first term, n is equal to 1. 1 minus 1 is 0, and that's 3 plus 0 times 5, which is just 3, and that's what we have here. If we're looking at our second term, n is equal to 2. 2 minus 1 is just 1. 1 times 5 is 5. 3 plus 5 is 8, and that's exactly what we have here. If we're looking at our third term, n is equal to 3. 3 minus 1 is 2. 2 times 5 is 10, plus 3 is 13, and that's exactly what we have here. So we know that this formula is going to work, and this is exactly what we have as our general formula for this sequence here. So I like to write this down as just a more simple way of looking at it. This is exactly the same thing as what we have here. And when we have something like this, we can actually simplify it even further, and we can expand that out. 3 plus 5n minus 5. So we have our 5n, and 3 minus 5 is equal to minus 2. So our general formula is that Tn is equal to 5n minus 2. So now we have our general formula for this sequence. And now let's use this formula to actually find T6 and T7. So I'm going to give myself a little bit more space here. So we have our general formula here, and we're trying to find T6 and T7. So if we're trying to find T6, we know we're going to be able to find that by seeing what 5 times 6 minus 2 is. And that is, well, 5 times 6 is 30, minus 2 is equal to 28. Now let's see what T7 is. We have to do 5 times 7 minus 2. 5 times 7 is equal to 35, minus 2 is equal to 33. 3. So that's one way that you can easily find any term in a sequence if you have your general formula for this sequence. You just have to plug in a value for n, which is whatever term you're trying to find, and you can find the value of that term. Let's go over one more example, and we're going to use the same strategy, and you're going to find that this is a strategy that's going to work pretty much all the time when you have a common difference. So let's say you were given this sequence, 15, 23, 31, and 39. Well, the first thing we can try to do is see if we can find a common difference. 23 minus 15 is going to be equal to 8. 31 minus 23 is also going to be equal to 8. 39 minus 31 is also going to be equal to 8. So we do have a common difference here. And so we can write down our sequence. We can see that we're adding 8 each time. And now we can start off by writing down our first term. And we're going to be adding 8 0 times. Now for our second term, it could be described as 15 plus adding 8 one time. So we're going to add 1 times 8. For our third term, we can go from 15 and adding 8 2 times, 2 times 8. And for our fourth term, 15 plus 8 2 3 times, so 3 times 8. So here we have T1, here we have T2, here we have T3, and here we have T4. And we can see that when we have T1, we're going to be multiplying by 0. When we have T2, we're multiplying by 1. When we have T3, we're multiplying by 2. And when we have T4, we're multiplying by 3. So we can write down our general formula as 15 plus 8 times n minus 1. And if we want to find an even more simplified version of that, we can expand that out. 15 plus 8n minus 8. 15 minus 8 is going to be equal to 7 plus our 8n. So Tn is equal to 7 plus 8n. And that is our general formula for this sequence. So now let's try and use that general formula that we've just figured out here. And let's say you had a question that said if Tn is equal to 175, what is n? So here they're telling you that one of your terms is going to have a value of 175, and you have to determine which term that is. Which term in this sequence with this general formula is going to have a value of 175? Well, now that we have our general formula for our sequence, we can just plug in 175 for Tn and solve for n. So we would write this as 175 is equal to 7 plus 8n. 175 minus 7 is going to be equal to 168. So 168 is equal to 8n. And if we divide both sides by 8, then we're going to be left with 21 is equal to n. So our n here is equal to 21. Our 21st term of this sequence will have a value of 175.